An ionic bond is defined as the electrostatic attraction between oppositely charged ions. In this lesson, we will learn about ionic bonding in lithium fluoride and potassium oxide. Lithium is a group 1 metal and will therefore have one electron in its valence shell. Its electronic structure is 2,1. Fluorine is a halogen and has 7 electrons in its valence shell. Its electronic structure is 2,7. Lithium transfers its valence electron to fluorine, forming a lithium ion and a fluoride ion. It's a common misconception that there must be 8 electrons in an electron shell for a species to be stable. As long as the electron shell in question is full, it will be stable. This is seen with lithium. The first electron shell can only hold 2 electrons, and this shell is full. So a lithium ion is stable. Note that it has the same electronic structure as a helium atom. The lithium ion and fluoride ion are oppositely charged and will be electrostatically attracted to one another, thereby forming an ionic bond. Let's have a look at the next example. Let's grab a piece of paper and pencil and draw the electronic structure of potassium and oxygen. Please pause the lesson and resume once you are done. Here are the structures. We can see that potassium has 1 valence electron and oxygen has 6 valence electrons. If potassium transfers its valence electron to oxygen, oxygen will only have 7 electrons. Oxygen will want 1 more electron to fill its valence shell, and it gets this electron from another potassium atom. So, 2 potassium ions are formed, and these 2 will be electrostatically attracted to the oxide ion. Note that the charges are fully balanced, so potassium oxide has an overall neutral charge. In summary, when oppositely charged ions come together to form an ionic bond, the charges must fully balance out to form an overall neutral ionic compound.